I can use the cosine ratio to solve for the missing side of a right triangle. So we're going to do a quick experiment here. I'm going to go ahead and circle our reference angle. And I'll do that for each one to start. And from that reference angle, let's label our sides. This will be the hypotenuse in all three cases. And then what's that other side that we have? If you take a look at it, you can tell that that has to be the adjacent to 37 degrees. So I'm going to go ahead and mark that up. And I can do the opposite as well if I like, but nothing's been given over there, so I'm going to hold off on that one for a moment. Now, what is the cosine of 37 degrees? Well, in this case, we're looking at the adjacent, and you might be wondering, how do I remember that? At the top of every page, we should have SOHCAHTOA, and we're dealing with cosine here, C for cosine, so adjacent and hypotenuse. So the cosine, 37 degrees, is going to be the adjacent, in this case, 8 over 10, the hypotenuse. This one here is going to be 12 over 15. And this one over here, it'll be 28 over 35. And if we reduce each of these, we notice they come down to 4/5, each and every one of them. So the cosine of 37 degrees in all three of these right triangles happens to be 4 over 5 when you reduce it. And that's because these are all similar by angle. They have a 90 and a 90, and a 37 and a 37. So the sides have to be proportional. So when we write them as ratios, they have to be equal. So they'll reduce down to the same thing. So why don't we go ahead and say that. The cosine of 37 degrees is 4 over 5, or we can call that 0.8 or 8/10 for all three triangles. And you might be wondering where 8/10 came from. Think of 4 over 5. If you multiply by 2 and 2, you get 8 over 10, and 8/10 is just 8/10. So what do we really mean when we say cosine of 37 degrees? Well, we can think of it as equaling 8/10, and what we mean is all right triangles with a 37-degree angle will be similar by angle-angle similarity. Therefore, the ratio is the side adjacent to the 37 to the hypotenuse will be proportional. Proportional. There we go. So we can use these ideas down below. Let's zoom in on our first example, and we're going to do it two different ways. So here's our first one. It says solve for BC. That's what I'm really looking for. So if I solve for BC, I'm just going to go ahead, circle that here. It's my goal. But I want to look at my reference angle first, as always. And I see that it's angle B. And what I can do is I can create another similar triangle right here. And the cosine of B is going to be 0.9, which is really 9/10. But what is 9 and 10? Well, if it's cosine, if we look at the top of our page, SOHCAHTOA, that's adjacent over the hypotenuse. So this here is my reference angle B. Here's my adjacent. Here's the hypotenuse. And so the adjacent over hypotenuse is going to be 9 over 10. And so if we take a look at this, we can see fairly clearly. You can think of this like your x. It's what you're looking for, distance from C to B. You can just put an x there if it makes you feel better. Okay, there's a fraction, there's a fraction. We can go ahead and write it out. We can say if we want 15 over x is equal to 10 over 9, or x over 15 is equal to 9 over 10. It won't matter. And I'm going to go ahead and cross multiply. 90, and that's 45 for 35, so 135. And then we'll go ahead and divide both sides by 10. And we can slide the decimal point once and get 13 and 5/10. So that's the way by setting up similar triangles. The other way is to just take this relationship, copy it over here. I'll rewrite the decimal though, 9/10 as the fraction 9/10. This is still my reference angle. And what is the cosine of B? Well, in this case, that would be adjacent over the hypotenuse. And so we can just go ahead and substitute in. The adjacent in this case is BC, or maybe you wanted to call it X, doesn't matter, over 15. And it's equal to 9 over 10. And so we have the exact same setup that we did over here, and we would just cross multiply and solve from there. So like tangent and sine, we're going to use cosine to find the missing side of a right triangle. This all works because of similar triangles. We're just going to set up a proportion, cross multiply, and solve. You can try this one down below as a check-in question, see how you're doing. Okay, here I go. Pause it if you haven't had time. I'm going to rewrite cosine of A is equal to 8 over 10. 8/10 is 8/10. My reference angle A here. My adjacent. My hypotenuse, my opposites across the way. And so for cosine, I want adjacent over hypotenuse. So my adjacent in this case will be 9. And my hypotenuse is going to be AB, which is what I'm looking for. Again, if you don't like using AB, you could just put an X here. And now we're going to go ahead and cross multiply. But before I do, I'm actually going to reduce the 10, and it'll make it a little bit easier. So this will be 9 over AB is equal to 4 over 5. And now I'll cross multiply. And if I do that, I'm ending up with 4 times AB is equal to 45. Let's divide both sides by 4, and we finally get the distance from A to B is 45 over 4, which is fine. But if we go and do that as a decimal, I'll have to do a little long division off to the side. Goes in once. Goes in once. Goes in twice. For 8, I'm out of room here, but it's going to be a 2 left. And if I bring the other 0 down with the 2, that makes it 20. It'll go in 5 times, and that'll be it. But the answer is not 11 and 25 hundredths. The answer is 11 and 3 hundredths because I'm rounding to the nearest tenth. So the distance from A to B is approximately equal to 11 and 3 hundredths. Excuse me, tenths, 3 tenths. Watch out for the rounding. Okay, good luck.